Investigating the potential causes of a partial power outage in a home is a systematic process. The initial assessment involves considering several factors and possibilities. The two initial guesses of a transformer going bad and loose feeders are reasonable starting points. Firstly, the possibility of a transformer going bad should be explored. Storms in the area could have caused damage to the transformer due to lightning or power surges. These events can lead to transformer malfunction and subsequent power loss. Secondly, consider loose feeders. While less probable than a transformer issue, damaged feeders could cause a complete loss of power if both are affected. However, the reported presence of power in some breakers suggests that this might not be the primary cause. Other possibilities to consider include a faulty electrical panel, lightning damage, and load balance issues. The electrical panel was recently upgraded, so it's important to consider the possibility of installation errors or defective components within the panel itself. Lightning damage is a significant concern given the storms. Lightning can cause breakers to trip, or in some cases, remain on without providing power. Load balance issues are less likely because the upgraded panel should be capable of handling the electrical load. Considering all the information, the most likely culprits are a failing transformer and lightning damage. The recommended steps to diagnose the problem are firstly to check the transformer for any visible signs of damage, such as burnt wires or oil leaks. Secondly, carefully inspect the electrical panel for loose connections or damaged components. If unsure or uncomfortable with these checks, seek help from a qualified electrician to diagnose and repair the problem. A systematic approach is vital in troubleshooting electrical issues. Firstly, gather information about the situation. The information includes the homeowner's observations, such as the breakers being on without power, the delay in power restoration, and the neighbor's reports of blinking clocks. These details can provide clues about the nature of the problem. Secondly, consider external factors such as the weather. The storms in the area suggest that lightning or power surges could have played a role in the power outage. These events can damage electrical equipment and cause various problems. Thirdly, evaluate the condition of the electrical system. The recent panel upgrade is a relevant piece of information. A new panel should be able to handle the electrical load, but it's possible that there were installation issues or defective components. Check the transformer for signs of damage, such as burnt wires or leaking oil. Inspect the electrical panel for loose connections or damaged components. Use a multimeter to test the voltage at the main breaker and individual circuits. This can help identify any voltage drops or abnormalities. Consider the possibility of a neutral wire issue. A loose or damaged neutral wire can cause voltage fluctuations and power problems. Check the neutral connections at the panel and other points in the electrical system. If the problem persists, contact a qualified electrician to diagnose and repair the problem. Electrical work can be dangerous, so it's important to prioritize safety. Before working on any electrical equipment, turn off the power at the main breaker. Use insulated tools and wear appropriate safety gear, such as gloves and eye protection. If you are not comfortable working with electricity, call an electrician to handle the problem. Troubleshooting electrical issues requires a systematic approach and a focus on safety. By gathering information, considering external factors, evaluating the electrical system, and seeking professional help when needed, you can effectively diagnose and resolve power problems in a home. Electrical systems often appear complex, but understanding basic principles can greatly assist in troubleshooting. When dealing with a situation where breakers are on but there's no power, the first step is to understand the layout of the electrical panel. This involves identifying which breakers control which circuits. Check if the affected circuits are on the same leg of the panel. If circuits on both legs are affected, it suggests a problem with the main supply or a component affecting both legs. Use a multimeter to check the voltage at the main breaker. A reading significantly lower than the expected voltage, typically 240 volts for split-phase system in the United States, indicates a problem with the incoming power supply. If the voltage at the main breaker is normal, check the voltage at individual breakers. A lack of voltage at specific breakers suggests a problem with those breakers or the wiring connected to them. An important component to inspect is the neutral bus bar in the electrical panel. A loose or corroded connection on the neutral bus bar can cause a variety of electrical problems, including a lack of power in certain circuits. Check the grounding system. A poor ground connection can also cause electrical issues. Ensure that the grounding electrode conductor is properly connected to a grounding rod or other grounding electrode. If lightning is suspected, check for signs of damage to surge protective devices. These devices are designed to protect electrical equipment from voltage spikes, but they can be damaged by lightning strikes. If a surge protective device is damaged, it may need to be replaced. The process of elimination is essential in troubleshooting. Start with the most likely causes and systematically rule them out. If the problem is not immediately apparent, it may be necessary to call a qualified electrician to perform a more thorough investigation. Electrical work can be dangerous, so it's important to take precautions. Turn off the power to the affected circuits before working on any electrical equipment. Use insulated tools and wear appropriate safety gear. If you are not comfortable working with electricity, call an electrician to handle the problem. Remember that electrical codes and regulations vary depending on location. Consult local codes and regulations before performing any electrical work. This ensures that the work is done safely and in compliance with applicable standards. When dealing with electrical issues, documentation is important. Keep a record of the steps taken to troubleshoot the problem, as well as any findings or observations. This documentation can be helpful if you need to call an electrician for assistance. Understanding the electrical system and following a systematic approach can greatly increase the chances of successfully troubleshooting power problems. Remember to prioritize safety and seek professional help when needed. To further elaborate on the potential transformer issues, one must understand the role of a transformer in residential power distribution. The utility company typically provides high voltage power to a neighborhood transformer. This transformer steps down the voltage to the standard residential voltage, such as 120 volts or 240 volts. A failing transformer can exhibit several symptoms. Firstly, there may be a complete loss of power to the house. Secondly, there can be intermittent power outages. Thirdly, there may be voltage fluctuations. Fourthly, there could be unusual noises coming from the transformer. If any of these symptoms are present, it's important to contact the utility company immediately. Do not attempt to repair the transformer yourself, as this can be extremely dangerous. The utility company has trained professionals who can safely diagnose and repair transformer problems. Regarding loose feeders, it's crucial to understand the configuration of the electrical service to the house. Typically, our residential service consists of 2 hot wires, a neutral wire, and a ground wire. These wires run from the utility transformer to the main disconnect in the house. If any of these wires become loose or damaged, it can cause a variety of electrical problems. Firstly, there could be a complete loss of power. Secondly, there may be intermittent power outages. Thirdly, there may be voltage fluctuations. Fourthly, there could be flickering lights. Loose connections in the electrical panel can also cause problems. Over time, connections can loosen due to vibration, temperature changes, or corrosion. Loose connections can cause arcing, which can generate heat and potentially start a fire. It's important to periodically inspect the electrical panel for loose connections. Tighten any loose screws or connections to ensure a good electrical contact. When inspecting the electrical panel, also look for signs of corrosion. Corrosion can occur due to moisture or exposure to certain chemicals. Corroded connections can cause resistance, which can generate heat and lead to electrical problems. Clean any corroded connections with a wire brush or other appropriate cleaning tool. Apply corrosion inhibitor to help prevent future corrosion. Lightning strikes can cause significant damage to electrical systems. Lightning can enter a house through power lines, phone lines, or cable lines. Lightning can also strike the ground near a house and induce voltage surges in the electrical system. Surge protective devices are designed to protect electrical equipment from voltage spikes caused by lightning. These devices typically consist of metal oxide varistors, MOSFETs, which divert excess voltage to ground. Surge protective devices can be installed at the main electrical panel or at individual outlets. It's important to install surge protective devices to protect sensitive electronic equipment such as computers, televisions, and appliances. Even with surge protection, lightning can still damage electrical equipment. Direct lightning strikes can overwhelm surge protective devices and cause damage. After a lightning storm, it's a good idea to inspect the electrical system for any signs of damage. Look for trip breakers, damaged outlets, or unusual behavior of electrical equipment. If you suspect lightning damage, contact a qualified electrician to perform a thorough inspection. Load balancing is an important aspect of electrical system design. In a split-phase electrical system, the load should be evenly distributed between the two hot legs. An unbalanced load can cause excessive current flow on one leg, which can lead to overheating and potentially damage electrical equipment. To balance the load, distribute appliances and lighting circuits evenly between the two hot legs. Use an ammeter to measure the current on each leg. If the current is significantly higher on one leg, move some circuits to the other leg. In addition to the potential causes already mentioned, there are a few other possibilities to consider. Firstly, there could be a problem with the electric meter. The electric meter measures the amount of electricity consumed by the house. If the meter is malfunctioning, it could cause inaccurate readings or a complete loss of power. Secondly, there could be a problem with the utility company's equipment. Power outages can be caused by problems with the utility company's transmission lines, substations, or other equipment. If you suspect a problem with the utility company's equipment, contact them directly. Thirdly, there could be a problem with the wiring inside the house. Over time, wiring can deteriorate due to age, corrosion, or damage. Damaged wiring can cause a variety of electrical problems, including a loss of power, flickering lights, or electrical shocks. If you suspect a problem with the wiring inside the house, contact a qualified electrician to perform an inspection. They can identify and repair any damaged wiring. Electrical troubleshooting requires a systematic approach and a thorough understanding of electrical principles. By considering all the potential causes and following the appropriate diagnostic steps, it's possible to identify and resolve most electrical problems. Always remember to prioritize safety when working with electricity. Turn off the power to the affected circuits before working on any electrical equipment. Use insulated tools and wear appropriate safety gear. If you are not comfortable working with electricity, contact a qualified electrician to handle the problem. Let's delve further into the technical aspects of transformers and their potential failures. Transformers operate on the principle of electromagnetic induction. They consist of two or more coils of wire wound around a common core. When alternating current flows through one coil, called the primary winding, it creates a magnetic field. This magnetic field induces a voltage in the other coil, called the secondary winding. The ratio of the number of turns in the primary winding to the number of turns in the secondary winding determines the voltage transformation ratio. A step-down transformer has fewer turns in the secondary winding than in the primary winding, resulting in a lower voltage output. Transformer failures can occur for various reasons. Firstly, insulation breakdown can lead to short circuits within the transformer. The insulation between the windings can deteriorate over time due to heat, moisture, or contamination. When the insulation fails, it can cause a short circuit, which can damage the transformer and interrupt power flow. Secondly, overheating can damage the transformer. Transformers generate heat due to losses in the core and windings. If the transformer is overloaded or improperly cooled, it can overheat. Overheating can damage the insulation and other components of the transformer, leading to failure. Thirdly, lightning strikes can damage the transformer. Lightning strikes can generate high voltage surges that can damage the transformer's windings, insulation, and other components. Surge protective devices can help protect transformers from lightning strikes, but they may not be able to prevent all damage. Fourthly, mechanical damage can cause transformer failure. Mechanical damage can occur due to impacts, vibrations, or other external forces. Mechanical damage can damage the transformer's core, windings, or other components, leading to failure. Identifying a failing transformer can be challenging, but there are several signs to look for. Firstly, there could be a complete loss of power. Secondly, there may be intermittent power outages. Thirdly, there could be voltage fluctuations. Fourthly, there may be unusual noises coming from the transformer. Fifthly, there could be overheating. Sixthly, there could be smoke or fire. If any of these signs are present, it's important to contact the utility company immediately. Do not attempt to repair the transformer yourself, as this can be extremely dangerous. The utility company has trained professionals who can safely diagnose and repair transformer problems. Furthermore, let's explore the intricacies of feeder cables and their role in power distribution. Feeder cables are the conductors that carry electrical power from the service entrance to the branch circuits within a building. They are typically sized according to the National Electrical Code, NEC, to ensure that they can safely carry the expected load. Feeder cable failures can occur for various reasons. Firstly, overloading can cause the cables to overheat. If the cables are carrying more current than they are rated for, they can overheat, which can damage the insulation and lead to failure. Secondly, physical damage can damage the cables. Physical damage can occur due to impacts, abrasion, or other external forces. Physical damage can damage the insulation and conductors of the cables, leading to failure. Thirdly, corrosion can corrode the cables. Corrosion can occur due to moisture, chemicals, or other environmental factors. Corrosion can weaken the conductors of the cables, leading to failure. Fourthly, loose connections can cause arcing. Loose connections can create resistance, which can generate heat and cause arcing. Arcing can damage the cables and other electrical components. Identifying feeder cable failures can be challenging, but there are several signs to look for. Firstly, there could be a complete loss of power. Secondly, there may be intermittent power outages. Thirdly, there could be voltage fluctuations. Fourthly, there may be overheating. Fifthly, there could be smoke or fire. If any of these signs are present, it's important to contact a qualified electrician immediately. Do not attempt to repair the feeder cables yourself, as this can be extremely dangerous. A qualified electrician has the knowledge and tools to safely diagnose and repair feeder cable problems. When addressing the possibility of a faulty electrical panel, it's crucial to understand the components and functions of an electrical panel. An electrical panel, also known as a breaker box or load center, is the central distribution point for electrical power in a building. It receives power from the service entrance and distributes it to the various branch circuits. The electrical panel contains several components, including the main breaker, branch circuit breakers, neutral bus bar, and ground bus bar. The main breaker is the primary disconnect for the electrical system. It allows you to shut off all power to the building in case of an emergency. Branch circuit breakers protect individual circuits from overcurrent. They trip when the current exceeds the breaker's rating, preventing damage to the wiring and equipment. The neutral bus bar provides a common connection point for the neutral wires of the branch circuits. The ground bus bar provides a common connection point for the grounding wires of the branch circuits. Electrical panel failures can occur for various reasons. Firstly, breaker failures can occur. Breakers can fail due to age, wear, or manufacturing defect. A failed breaker may not trip where it should, or it may trip unnecessarily. Secondly, bus bar corrosion can corrode the bus bars. Bus bar corrosion can occur due to moisture, chemicals, or other environmental factors. Corroded bus bars can cause resistance, which can generate heat and lead to electrical problems. Thirdly, loose connections can cause arcing. Loose connections can create resistance, which can generate heat and cause arcing. Arcing can damage the panel and other electrical components. Fourthly, physical damage can damage the panel. Physical damage can occur due to impacts, vibrations, or other external forces. Physical damage can damage the panel's enclosure, breakers, or other components. Identifying electrical panel failures can be challenging, but there are several signs to look for. Firstly, there could be breakers that trip frequently. Secondly, there may be flickering lights. Thirdly, there could be unusual noises coming from the panel. Fourthly, there may be overheating. Fifthly, there could be smoke or fire. If any of these signs are present, it's important to contact a qualified electrician immediately. Do not attempt to repair the electrical panel yourself, as this can be extremely dangerous. A qualified electrician has the knowledge and tools to safely diagnose and repair electrical panel problems. To provide a comprehensive perspective, let's discuss the impact of lightning damage on electrical systems. Lightning strikes can generate extremely high voltage surges that can damage electrical equipment in various ways. Firstly, direct strikes can cause extensive damage. A direct lightning strike can cause massive damage to electrical equipment, including transformers, electrical panels, and wiring. The high voltage and current can melt conductors, shatter insulators, and ignite fires. Secondly, indirect strikes can also cause damage. Indirect lightning strikes can induce voltage surges in electrical systems, even if the lightning does not directly hit the equipment. These surges can damage sensitive electronic equipment such as computers, televisions, and appliances. Thirdly, ground surges can damage equipment. Lightning strikes can create ground surges, which are voltage spikes that travel through the ground. These surges can damage underground wiring and equipment. To protect electrical systems from lightning damage, several measures can be taken. Firstly, install surge protective devices, SPDs. Surge protective devices can divert excess voltage to ground, protecting electrical equipment from damage. SPD should be installed at the main electrical panel and at individual outlets. Secondly, use lightning rods. Lightning rods can attract lightning strikes and safely conduct the current to ground, preventing damage to the building and its contents. Thirdly, ground electrical equipment properly. Proper grounding can help reduce the risk of damage from lightning strikes and other electrical faults. Fourthly, disconnect electronic equipment during storms. During lightning storms, it's a good idea to disconnect sensitive electronic equipment from the power supply to protect it from voltage surges. After a lightning storm, it's important to inspect the electrical system for any signs of damage. Look for trip breakers, damaged outlets, or unusual behavior of electrical equipment. If you suspect lightning damage, contact a qualified electrician to perform a thorough inspection. They can identify and repair any damaged wiring or equipment. Finally, let's address the concept of load balancing in electrical systems. Load balancing is the process of distributing the electrical load evenly between the phases of a three-phase electrical system or the legs of a split-phase system. In a split-phase system, such as the one typically found in residential buildings in the United States, the electrical service consists of two hot wires, a neutral wire, and a ground wire. The two hot wires are 180 degrees out of phase with each other, providing 240 volts between them. Each hot wire provides 120 volts to the neutral wire. An unbalanced load occurs when the current draw on one hot wire is significantly different from the current draw on the other hot wire. This can cause several problems, including firstly, voltage drops. An unbalanced load can cause voltage drops on the heavily loaded hot wire, which can affect the performance of electrical equipment. Secondly, overheating can occur. An unbalanced load can cause the heavily loaded hot wire to overheat, which can damage the wiring and equipment. Thirdly, transformer inefficiency can result. An unbalanced load can cause the transformer to operate inefficiently, which can increase energy costs. To balance the load, distribute appliances and lighting circuits evenly between the two hot wires. Use an ammeter to measure the current on each hot wire. If the current is significantly higher on one hot wire, move some circuits to the other hot wire. In addition to balancing the load between the hot wires, it's also important to balance the load on each circuit. Avoid overloading individual circuits, as this can cause the breaker to trip. If you frequently trip breakers, it may be necessary to add additional circuits to distribute the load more evenly. Load balancing is an important aspect of electrical system design and maintenance. By ensuring that the load is evenly distributed, you can improve the performance, efficiency, and safety of the electrical system.